Assalamualaikum and good morning. Today, our group would like to present about vector and scalar in architecture. Our lecturer name is Tuan Muhammad Anwar bin Idris and our class is DKA 1B. Okay, now I would like to continue our slide to group member. First, Naga Vaishnavi, anak perempuan Sukumaran. Okay, second, me, Muhammad Syamil Aizat bin Encik Razali. And the third one is Akmal Haikal bin Faizal. Okay, next, introduction. Definition of scalar. A scalar is a quantity that is completely described by its magnitude alone. For example, area, length, mass, temperature, and speed. After that, definition of vector. A vector is a quantity that is not completely determined until both a magnitude and a direction are specified. For example, velocity, force, displacement, and acceleration. Okay, next, I would like to continue about definition of vector addition. Definition. If U and V are vector position, so the initial point of V is the terminal point of U. The sum U plus V is the vector whose initial point is the initial point of U and whose terminal point is the terminal point of V. Okay. We can refer from the triangle law and the parallelogram law.
Now I will continue for another slide. How vectors are used in engineering. Represent quantities and that have both of magnitude and a direction. Many engineering quantities such as force, displacement, velocities, and accelerations will need to be represented as vectors for analysis. Real-life application of vector. Vectors can be used in many fields such as navigation of aeroplanes, ships, and satellites. They are also used in gene cloning. They are widely used in mechanics, physics, and computer engineering. They are also used in graphics by creating a smaller and adding them to get an real object. Examples: force, torque, velocity, crosswind, roller coaster. Example 1. A ball is thrown with an initial velocity of 70 feet per second at an angle of 35 degrees with the horizontal. Find the vertical and horizontal component of the velocity. Let V represent the velocity and use the given information to write V in anti-vector form. V sama dengan 70 cos 35 darjah I tambah 70 sin 35 darjah. Simplify the scalars we get. V sama dengan 57.34I tambah 40 per 15 I. Since the scalars are the horizontal and vertical component of V, therefore the horizontal component is 57.34 feet per second and the vertical component is 40.15 feet per second.
Hello, good morning to sir and my beloved friend. My name is Nagavishnu daughter of Sugumaran and my matrix number 01DKA21F1070 and I'm from DKA1B. Example 2. A cable as shown beside is used to center the top of a pole to a point on the ground. The cable has a tension force of 3 kN that act along the direction of the cable as shown beside. What are the X, Y, and Z components of the tension force acting on the top of the pole? For the solution, we must use Pythagoras theorem. So, 3 square plus 6 square plus 2 square equivalent 7 meter. And then tension of X negative 3 divided by 7 and then times by 3 kilonewton, we will get 1.29 kilonewton. The next is tension of Y negative 6 divided by 7 and then times by 3 kilonewton, we will get negative 2.57 kilonewton. The last is tension of that negative 2 divided by 7 and then times by 3 kilonewton, we will get negative 0.86 kilonewton. Okay, so as a conclusion, vectors have a crucial role in our daily life as well as in engineering. In engineering mechanics, vectors are used to express quantities that have both a magnitude and a direction. For analysis, many engineering quantities such as forces, displacements, velocities, and accelerations must be represented as vectors. That's all from us. Thank you.